Alright, so here we have the two new motors from EMAX. These are the new RS2 2206 and 2306 motors. And as I showed on the preview, these come in several different kV values. So they pretty much cover the whole kV range from low kV to high kV. So that's pretty good. You can just pick any kV you want, and most likely it'll be offered by this new series of motors. So what EMAX is saying about these new motors is that they're going for lightness, because in a lot of the applications, like for racing, the focus is on making the motor as light as possible, just to have your whole build light and still be quite powerful. And these have built upon the previous experiences with the original RS line and the recent LS series of motors. So they've incorporated what they've learned on those previous two series, and they've used that knowledge for these motors. So pretty good. EMAX is always trying to get the most out of their motors. So they've also done away with the usual plastic box, and now they come in these cardboard boxes with foam. Those plastic boxes thought they weren't needed, you know, and if this can help keep the price down and keep all that plastic out of the environment, that's good. Still, this foam is not that environmental friendly, so it'd be good if all the companies start to show concern for using recyclable materials in packaging. You know, that's always good. So the usual from EMAX, they give you plenty of hardware and nicely labeled. Screws for 4 and 3 millimeter arms, and they also give you an extra shaft retaining screw and a washer, and of course the standard nylock. So improvements on this motor have been quite a few actually. And the most important being the shaft. They've gone to a full titanium one-piece hollow shaft. So that's pretty good. That's gonna make this shaft quite strong and not easy to bend on crashes. And the base, as you can see, is the naked bottom base, minimal base to save weight, and that's a 16 by 16 pattern. And as you can see, the usual features, shaft retaining screw, and this time they've gone to a single wire for the windings, and they maintain the armature or similar armature to the LS series anyways, because that gave them a very light framing for the motor. So let's get some weight on this motor. This one is the 2306, and they come with about 125 millimeters of 20 gauge wire. So we'll weight that with this factory wire, length of wire. And let's see, so that comes in at 29.2 with that much wire. So if we leave the wire at about 50 millimeters, then we'll remove that much. This is a little bit longer than what we need to cut, but anyway, it'll give you an approximation. So let's say that's around 2 grams or so, 2.3. So let's tear that with 50 millimeters worth of wire. It comes in at 26.8. So very light for a 2306, actually quite amazing weight at 26.6 grams with 50 millimeters length of wire. So they list them at 26.6 without any wire, so it may actually be a little bit lower than that, or at least for sure it's going to be 26.6. So really light motor, very good from EMAX. A lot of people really look for as light components as possible. And so here's the 2206. Pretty much the same design on the armature. They're pretty much identical as far as the bell design and the base. So of course the only difference is going to be in the stator. And I'll crack them open just to see what size the shaft and the bearings are for each of these motors. So let's have a weight on the 2206. Let's see the weight. And again, this one comes in with about 120 millimeters of wire. So let's see what that weighs. And that comes in at 29.4. So if we remove that much wire, then that's 27.2. So that's actually kind of surprising. The 2206 is a little bit heavier than the 2306. They have the same height on the stator, and this one's actually a little bit wider, so it could be in the magnets, could be maybe this one has a little bit more balance in mud, but for all practical purposes these are identical weight on both these motors, so that's interesting. The screw on the shaft is a little bit on the tight side. They're using that white thread lock, so that one's kind of hard to break loose. So I usually like to heat up the screw with a soldering iron. Just leave it there for 5 to 10 minutes. I always touch the motor. It's always comfortable to touch. So far that's been working pretty well. I imagine there's not that much heat transfer from the screw through the shaft, through the bearing, and out to the stator. So it usually heats up the screw pretty well, and it loosens the thread lock. So, but still, you know, make sure you check the motor temp. Make sure it's not scalding hot. You know, we don't want to overheat the stator. Though I never had that issue. You know, just leaving the soldering iron there for up to 10 minutes. I've done that on a lot of motors, and I can always hold them pretty firm like that, and never burnt myself. So anyways, I've loosened this previously, so they're already loose. So this one's the 2306, and the screw is pretty small. I wish they changed that to the larger head screw. Although this one came out pretty easily, heating it and using this 1.5 millimeter driver. This is not the best quality driver, but seems to work quite well. That's why you want to make sure that it fits just right. If it's too loose, then what ends up happening is you ground the screw, and that messes it up, and it's just a hassle to have to use pliers to take it out. Pretty strong magnets. So there we go. And interesting, they do use some type of washer here. So that's a kind of like a countersunk washer, and as you can see there, the titanium shaft, it's got a kind of different base right there where it clamps onto the bell. So this looks like it's a 4 millimeter shaft. Originally I thought it was 3 millimeter before I cracked it open, because of the screw that we're using, but it is 4 millimeters. So 4 millimeter shaft. Alright, so here we have the 2306 bell. There's the titanium shaft, fully hollow. You can see through it right there. And very similar to the LS series of motors. And as you can see, there's the magnets, arc magnets, and balancing mud. And one interesting thing to note is the thickness of the magnets. As you can see on these, they kind of look thin compared to other motors. And one of the YouTube viewers I believe he's from Italy, and he's quite knowledgeable on motors and all sorts of electronic stuff. He was telling me that he was talking to his professor, I guess at university, and they were discussing the magnet thickness on the previous RS motors compared to these ones. And the professor was telling him that on the RS the magnets were too thick, and that most likely the back iron was saturated, the back iron being the ring around the bell. So that was being saturated, so meaning that you had, I believe that's a leakage of the flux field, the magnetic field, because the purpose of these, well, one of the jobs of the ring is to contain that or redirect the magnetic field into the stator, but obviously that's not possible to do 100%, so you always have some that gets through. So when you have really thick magnets, you end up with saturation on the ring, and that's not good. So designers have to balance the thickness of the magnets and of the back iron. So it seems that that's what they've done here on this new motor. They've optimized the magnet thickness so that it matches the output power that they're looking for, and it also matches the stator. That was quite interesting information from this YouTube viewer. So here we have the stator. This is the 2036 stator, and there you can see single strand wire on the winding, and the stator is supposed to be 6 millimeters height. Yeah, there it is, a little bit, it's a little bit taller than 6 millimeters. So yeah, 6 millimeters on that stator, 6.2 or so. And as usual from EMAX, very nicely wound stator, nice and neat. And those bearings, they are, looks like those are 4x8x3 bearings. I think they're 3 millimeters in depth, and these are made by ESO, so those are really good quality bearings. So hopefully on this motor the size bearing proves to be durable. Most people still prefer the larger bearings, but I'm sure EMAX just wanted to optimize the stator, so they went with a smaller diameter bearing. So this is one of the methods I use to pop the bearing out. I use a punch like this one, and you basically insert it through there. This is for the bottom bearing, and you want to rest it right on the inner race. And since most of the times if you're removing the bearings, because you're going to replace it, so like, you know, you don't have to be all that careful, but I'm going to try and just pop it out and reuse that bearing, so I want to be careful not to hit the shield. So I'll rest it right on the inner race. You just kind of just feel it. And there are other methods that are probably better than this, but that's what I use. And I'll just tap it, and then you do it on the other side, and again you tap it, and it'll pop right up. Usually they'll pop easily unless they're really tight. You have to use a little bit more force. So there it is. That's the ESO bearing. Let's get a measurement for sure. Inside diameter is 4 millimeters. So that's the shaft. Then the outside diameter is 8 millimeters. And the depth or thickness is going to be 3 millimeters. So that's a 4x8x3 bearing. ESO bearing. And to put it back in, there are several methods that you can use. Sometimes you'll reuse the old bearing and you'll use that to press the new bearing in, and you have to be careful not to mess up the windings, of course. So you can use a vise. It's a C-clamp, but it's kind of like a vise. So you'll have the old bearing right there, and another one of the old bearings right there. So you'll have two bearings of the old ones, and then two of the new ones that you're pressing in, and then you would put that right there and start turning, or with a vise, and so that would press both bearings in. Just make sure that you don't mess up the windings there. So the other method is to use a long screw, and you still use the old bearings as cushion to press the new ones in, and you'd pass the long screw through there with a nut and washers, and you start tightening the nut, and as you tighten it, it's gonna press the bearings in. So that's the other easy method. Yeah, 4mm shaft on the 2206 as well. There's the stator, same type of windings. They're almost identical, except for, of course, the diameter. And they're also using the same bearing, 4x8x3, and similar construction on the bell. Although on the 2206, it almost seems like the magnets are a little bit thicker, so that's interesting. Thicker magnets on the 2206. That's the overview of the motors. So let's put this back together, and we'll go ahead and put them on the thrust stand and see what they can do. Alright, so that was the thrust test runs for the new motor from EMAX, the RS2 2206 2700 kV. This one measured at 2670 kV, so slightly lower than the spec kV. So overall, very good performance out of the motor at very reasonable loads. As you can see, the loads are quite manageable. Keep in mind that these are maximum burst amps, so they only occur for a very short time. Eventually they do taper down, and in flight, as I always mention, the actual amps are gonna be much lower because the props are unloaded. My estimate is usually around 40% lower. That's just a rule of thumb. Of course, that varies depending on each specific setup, weight, type of battery, so many variables, but 40% it's a good rule of thumb. Of course, it could also vary. So 40% lower on 54 amps is going to be roughly around 30 amps in the air maximums. So that's just the max. You're only going to see that for like a split second on those very abrupt maneuvers. Actually, the loads are much more than that, but these are sustained maximum loads for a very short time, as I always mention. Comparing this motor to the results of the LS2206 2700 kV from EMAX, It's kind of interesting. Both motors are same size, but they're constructed differently. The LS is using multi-strand wire on the stator, and this one is single-strand wires. So it's quite interesting to see how those two types of stators perform. The LS 2206 2700 is actually slightly higher kV, so it's not quite a equal comparison, but it's close enough. So you can see that with this one, EMAX is achieving what they set out to do, which is a high performance motor with quite good efficiency is what they wanted. So comparing to the LS 2206 2700, you can see that this one is actually pulling lower amps than the LS series. The overall thrust is also slightly lower than the LS 2207 by 60 to about 100 grams in some cases. So it's not that bad considering that the amps are quite a lot lower. So that was the main goal I think that EMAX wanted on these light motors. So they optimized it for more efficient designs. So it looks like they did achieve their goal. So alright, that was the thrust test for this motor. Hope you find the results interesting. Thank you for watching, and until the next video.